This
Let's wait and see if we
conference will now be recorded.
have. Should we wait for anybody else to get here, or are we good? No? All right. Hopefully there's some people watching. If not, you'll get to watch it later. Okay. Um, well, let's get going then. So, my name is Jason Rohr, and I'm going to do a presentation today on being an automation engineer, and targeted mostly for people who do not know what this industry is and kind of go through what it is, what kind of person uh, works in this industry, what kind of jobs you'll do, and the kind of things you'll see. Uh, Jason Rohr, I'm a PE. I've been working in Alaska as an automation engineer for almost 20 years at a company called ATS Alaska, which was recently bought by Convergent Technologies. And then I left Alaska. I've actually been living in Oregon for the past few months, working at Meta as a controls subject matter expert, where I work to maintain data centers and make sure that they're working correctly from an HVAC point of view. So tons of experience. Hopefully I can share some of it today. And I'd just like to mention for anybody who is here today, lunch is being provided by Proctor Sales. And if you're not here yet, hope you're getting down here. There's going to be some good food. Okay, so starting off, what is automation in our context? Well, automation is basically a system of components that produce some outcome without user input, right? So as an automation engineer, we're going to be designing systems to produce some form of automation to produce some kind of output. And sounds complicated that way, but it's really just in our day and age, a computer system and a system of software controlling hardware to manage devices inside a building. I got a picture of a Rube Goldberg machine. That's a pretty basic version. Um, and one of the interesting things about this field is that by and large, I have found that it's a field that most people don't know exists. If you become an automation engineer, and a lot of people might call it the world of DDC or HVAC, it's difficult to explain to people what it is that you do because people don't understand that these systems are there seamlessly integrated into our buildings. If you walk into a building, lots of versions of automation might be simply a light switch, a light automatically coming on. The room is at the correct temperature, say 65 to 70 degrees. Most people walk into buildings and don't realize that there's a series of complicated mechanisms behind the scenes taking care of all this stuff for you, deciding when lights come on and off, deciding when to tell people to evacuate a building. You don't really know it's there until your fire alarm strobe goes off. You can't think straight and you have to get out of the building now. Um, and there are all kinds of automation. Outside of buildings, you can go into cars. Cars have internal temperature regulation systems that manage all that stuff for you. They have automation systems that tell you when you're driving off the road. There's all kinds of automation. And today we're going to focus a little bit on building construction. So what do we automate in buildings? Easy one, we're at an Ashrae meeting. Most of you are mechanical, and you're probably thinking from a mechanical point of view, HVAC, heating, ventilation, and air conditioning. And it's going to be our focal point for the rest of this. But what does that entail? So that means fans, pumps, temperature conditioning for a building or rooms for managing humidity control, temperature control. When do those pumps and fans turn on? What do they do when they turn on? How do you regulate the valves, heating and cooling valves for managing that temperature control? But there are a lot more automated systems in a building you probably don't think about, such as fire alarm, fire suppression. You have systems that detect when there is a presence of a fire in a building and tells people what to do, turns on suppression systems to try and put out that fire. Some of it's automatic mechanically, some of it's controlled by electronic automation systems. Access control. You're probably pretty familiar with access control badges that you walk around and wave in front of a little box in front of the door, and that box decides whether you get to get through the door or not by locking it unlocking it or leaving it locked. Um, Public address systems, you pick up a phone, hit a number, and announce a page throughout a building. Nurse call systems, there are systems for monitoring patients and immediately telling nurses that there's a problem with the patient, they need to get down there right away to go see what's going on. Uh, Infant abduction systems. Uh, there are systems for monitoring infants, checking to make sure they're okay, locking doors as soon as they head towards an outside door so they can't be taken by someone who does not, uh, who's not supposed to have them. Lighting. More than just a lighting switch, you have occupancy sensors. These are automated devices to determine if someone's in a room, or maybe a more complex scheduling system to automatically turn on lights and turn off lights in a room to save energy. And when it gets more interesting is when you start combining all of these systems. HVAC integrates with fire alarm and access control, nurse call, public address systems. Public addresses now have uh, lockdown buttons in schools thanks to our current climate of rotten people. Uh, so that someone in the front office can initiate a lockdown sequence and it goes over the public address saying everybody stay where you are. And that ties immediately into the access control system, and the access control system blocks everything down. Or maybe you have an access control system tied into your HVAC where a person badges in, walks into a building, then it tells the HVAC system, hey, person 392 is here. Turn on their office and turn on their lights. Uh, and this stuff can happen all seamlessly in the background. So the world of automation is really expanding right now at a huge rate. And who knows what we're going to see in the future, but as all these systems tie together and interoperate, it's an interesting time to be an automation engineer. But we're going to focus on HVAC. All right. Next. There we go. So in the world of HVAC, how do we automate? Well, for the longest time, it was a system called pneumatics, timer circuits, and relays. And pneumatics is essentially a system of tubes running throughout a building that were always maintained at a certain pressure. And then we used pressure to trigger relays, trigger actuators, trigger different mechanical components in order to produce the desired outcome. Air pressure would turn valves open and closed. Air pressure would trigger relays to turn fans on and off. It was actually pretty sophisticated at a heyday, but it had inherent issues. It was effective, but it wasn't very intelligent and it wasn't configurable. Had a hard time adapting to complicated occupied schedules. So if we want to save energy and we want to make sure the building is shut down at a particular time, which automation can do, pneumatic systems had a harder time and required much more manual control to do this. So as electronics and computers came to rise, we as an industry drifted more towards electronic boards that could manage inputs and outputs and be customized configurably to do exactly what we want. And so you'll come across two major types of electronic control in building automation. One will be DDC, which stands for Direct Digital Control, and one will stand for PLC, which stands for Programmable Logic Controller. DDC you'll primarily see in commercial buildings, and PLC you'll primarily see in industrial applications, wastewater treatment plants, power utilities, that kind of thing. So here we are at Ashrae. Why are we talking about automation, right? If you're a mechanical engineer, if you come out of school, you might think to yourself, I design flow rates and linkages, gears, pipes, ducts, heat exchange rates, all this kind of mechanical stuff, right? This is a piece of electronics. It's an electronics board with circuits. I don't care about that. Give that to the electronics group. So the electrical engineer takes a different tack and says, well, I'm going to design power infrastructure. I deal with conduit fill, panel boards, power quality. I'm energizing buildings. I'm making those pumps run, right? These little circuit boards are nuanced and they require programming, and that's not what I do. Give that to software engineers. So it goes over to computer science, right? Well, computer science says, I can look at this, but these are really simple. uh, Computer science person wants to design databases and video games and things of very high complexity. Besides, why do I care about duct pressure? And why is that different from pipe pressure? Why do I care about 120 volts? And why is that different from 480 or 24? That doesn't matter to me. And the truth is, automation is really a good blend of all three of these disciplines. So if you're a mechanical that likes computers, or an electronics guy who likes figuring out linkage systems, uh, these are good things that kind of blend together. Nobody who comes out of school really has all the bits and pieces to know how to be an automation engineer. They all have things to learn. And so just because you're in one of those particular fields, don't feel like it's uh, it's an area that's locked out, because everybody has to learn something like when they come in. A mechanical engineer comes out and doesn't understand why you shouldn't short these two 120-volt wires, or what a relay does. And the electrical person comes out not really understanding what a pump does, or why you should have to pay attention to how you're operating it. Uh, so it's something to keep in mind, that it's a unique blend of a trade, and that it requires a distinct set of skills and interests. What roles can an automation engineer have? Um, when you start out at a company that does automation engineering, and then we're talking primarily PLC and DDC work, there are four different prime roles in any given project that you're probably going to work on. And when you get started, you're probably going to start out as a field technician. A field technician goes out there, has to interpret drawings, has to look at how components are wired up, has to look at their input-output boards, decide, is my temperature sensor wired up to the correct input? Is my valve actuator tied up to the correct output? They have to make sure that the signals are transmitted correctly, make sure the signals are actually correct to do whatever the stuff is going to do. They have to troubleshoot field components, maybe send a signal to a pump and verify that the pump comes on. Same thing for a fan. When they get out there, they have to understand the drawings, and they have to understand mechanical systems, or whatever system they're controlling, understand how it works, so that when they test it out, they're the ones confirming that it actually does what we think it's going to do. And then they typically have a hand in commissioning, so that when they think they're done, someone, an engineer, consultant engineer usually, is going to come out there and say, all right, show me that this system does what we think it's going to do. And a lot of times that field technician has the role of demonstrating uh, what they have turned on and started up and done correctly. When you start out, technician sounds pretty exciting, because you get to get out there and see a lot of different stuff. As a newly graduated engineer, it might feel demeaning. Why did I get a degree in order to become a field technician? But it really is a very important role, and it really can be fun. It is good to get out and see things, but being the field technician, you get a true understanding for how things work and why things work, how they work well and how they don't work well out in the field. And it's really good to have that perspective, because that perspective helps you at some of your other roles in this particular job. So another role that we have is as the programmer. The programmer has to interpret the drawings and writes the program for the automation system in order to meet the sequence of operation. The programmer very often lays out a graphical layout of the HMI, or human machine interface, so that it's complete, intuitive, relatively easy to use, hopefully, if they have any aesthetic sense, and a little bit of practice and some guidance. If possible, they can test bench their system before it actually goes out for the technician to start up. The programmer often has to be a little bit more than just a programmer. Uh, a programmer often has to be something like a graphical designer. They're going to take information, and if you view it strictly as an engineer likes to see it, tables on a screen, a lot of times this becomes in, unreadable to a maintenance person. A lot of the maintenance people out there do not have the same engineering background as the people who might be doing the programming, or the same engineering train of thought. And so the programmer has the job of taking the information and putting it on the screen in a way that just about anybody can figure it out, because just about anybody is going to have to at some point. And they're going to have to understand what the system is doing at any given point in time, what it's trying to do versus what it's doing right now, maybe how to override it, maybe how to change set points and what those set points mean. And having done this for a lot of years, I've seen a lot of interfaces that people have created that just look like text thrown on a screen, and they're really annoying to work with. And so as a programmer, it's really good to try and figure out a good sense of aesthetic and how to show information in a way that other people are going to understand it. And not everybody has that, but everybody can learn it. All right, on to our next role as a designer. Here we go. This person has to interpret drawings again, but this person has to interpret, most likely, the construction drawing set. So your architect, your mechanical engineering firm, the electrical consultant firm, they're going to put together a series of drawings that describe a building, describe a system uh, that we have to analyze and figure out what's going in this building, what is this building trying to do, how am I going to control the equipment. So the designer is going to create a series of engineering plans, shop drawings of their own for whatever system they manage to meet the objectives of the project design. So they have to pick out how many control boards are we going to use? What is the input-output configuration of the control boards? What voltages are we going to be working with? What kind of sensors go into a particular place? Are these sensors appropriate? Do these sensors meet what the consultant engineer thinks I should be using? If I think we should be using something else, should I be telling them about it or just accepting it and moving forward? Uh, are the sensors going into an explosive environment, a wet environment, dry environment? What kind of thing am I measuring? Does the board have enough inputs and outputs to do what I want, or am I going to have to start getting creative? What am I controlling? How am I controlling it? Uh, am I controlling a pump that has a motor starter and it's got a simple dry contact interface for me to start stop, or do I have to get creative with power capable relays? Am I managing a VFD, a variable speed drive? And I'm not just stopping something, but I'm managing the speed that it runs so that I'm controlling some other process variable. The designer has to take a lot of things into account in order to produce their shop drawings. They often have to research third-party equipment. Perhaps you're going to get to control a boiler, or you're going to get to control a rooftop unit. You have to read about that equipment and figure out how it works and how you're going to make it do what you want it to do, or if it even can. Figure out your level of integration, fully understand it, and submit those drawings. The last step that we have is as a project manager. And the project manager maybe could just be a project management trained person who doesn't have to understand how automation works. Their job is to manage your client, whoever you work for. They manage subcontractors, or at least your installation crew. Their job is to manage the project schedule and make sure that we're doing all the right things at the right time, buying the material at the right time, managing documentation, managing when the technician runs out to do startup. Is our design done in time? Is our programming done in time? Go to sub meetings. It's often a lot of office work, but it's a good thing if the project manager has an understanding of what the previous three roles do so that you can accurately describe that information when you're going to sub meetings and they ask you a question and you don't just say, well, I'm going to talk with my engineer. You understand what goes into their jobs, what goes into their roles, so you can answer that information right away. So these are your primary roles. If you end up working at a large company, say I'm guessing Siemens or Johnson Control, you probably only get to do one or two of these roles. There's enough work that they do that it ends up getting split up. If you get the opportunity to work at a smaller company, and there are many of them scattered all over the place, not just in Alaska, with any luck, at a smaller company, you get to work many of these roles. I spent almost 20 years at ATS Alaska, and the model when I worked there was one person did all of these roles. And it might seem overwhelming, but it's actually a really fun design because you get a piece of everything. You get to understand everything, and understanding everything makes you better. Being that person who goes out into the field as the field technician makes you a better designer because you understand how things work out there. Being the designer who built the drawings, going out there and being the technician makes you a better technician because you understand why things were put together the way they were. Being the designer and the programmer makes the programmer better because again, you understand why the system was built. You don't have to think about it, you're putting it together. Makes you better. And as the project manager, you understand how all those field and design pieces go together. So when you're managing it and someone tells you you need to take care of this because that's your scope, uh, it's very easy for you to say, well, we can or cannot do that because you as the engineer understand what goes into some of those processes. And with any luck, you have the option of being in a role where you get to blend all of those roles because it makes you better at the rest of them and it makes you a much better engineer in the long run. All right. On to the next one. All right. So what does the engineer do? The engineer has a lot of stuff, and I may have gone over some of this already. um, Reading project drawings and specifications, right? We talked a little bit about that as the designer. The designer will pour through a drawing set. So if you haven't had the opportunity to look, you'll get to see them. Consultant engineers put out project plans that will show power locations for pumps and lights and fans, outlet locations, planned equipment locations, and you'll have to pour through these drawings and truly understand a building from multiple aspects. What's the equipment? Where is the equipment? Why is the equipment? I'm going to need power for my systems. How am I going to get that power? How am I going to distribute that power? There's that little bit of electrical engineer part of that, right? Now you have to worry about things like I'm going to put my transformer in X location in a building, and I'm going to use it to power all of my devices and all of my controllers. But how far can you take that power before you have voltage drop across your lines? How much capacity do you have before you're going to run out? Or maybe you have too much capacity running through a line and you have to increase the size of that line, duplicate that line, maybe put additional power supplies throughout a building. Now you have to figure out, where am I going to get that power? So reading the drawings helps you figure out how you're going to solve these problems as you go through about creating your design. Something the engineer has to pay special attention to is the sequence of operations. And the sequence of operations is essentially a written narrative about how everything in the building is going to work. At 8 in the morning, when the building goes into occupied period, all of the zones are going to go into occupied period and maybe change their temperature set points to match whatever we think occupants are going to want to have when they're there. When the building goes into unoccupied period, say at 5 p.m., maybe the building drops down to something lower, 60 or 65 degrees, because heat costs money and we want to spend less money. So we're going to let the building drop down to a lower energy consuming state. Maybe we'll turn off equipment that doesn't need to run, turn off the lights as they don't need to be on. Uh, Beyond just that, there are usually a fairly complicated narrative about how we want things to work in the correct way so that we don't damage it. We keep the building up in a place where it's going to keep going. So after you read the project drawings, you've got to break up your drawings into a series of individual systems. You have to look at air handlers and pump systems and try to determine, what's my IO count? What's my input output count? Inputs being things like uh, carbon dioxide sensors or temperature sensors, level sensors, airflow sensors, any sensor that is reading some physical medium, and we're going to take that into our card and we're going to turn that into digital information that I can now do something with. How many of those inputs do I need in the system in order to make the sequence of operation work? Same thing for outputs. How many outputs do I have? How many pumps do I have to turn on? How many fans? How many lights? How many damper actuators do I have to modulate? Fan, valves, etc. So you create your I/O count, and that helps you generate a list, roughly, of how many controllers you're going to need in your system. And then you lay that out. You have to figure out where those are going to go in a building. Can I put them all in one place? Do I have to distribute them throughout the building? When we're looking at the project drawings, we want to confirm things like connection sizes, pipes, dampers, ducts, rooms. We look at the drawings and we use that to create our drawing set. But in the end, we actually have to accept that some of those things are going to change. We actually have to work with our partners within the construction industry to verify that these are right. Consultant engineers might decide that a pipe or damper size is going to be X when it comes out on the drawings. It may not actually be that way when it comes to installation. And so we have to work very closely to make sure that when we make our design, we're matching what's actually going out into a building. Because if we don't, it may not work correctly. Maybe somewhere along the way, we have a design CFM rate to a certain room, and along the way, either that design changed, maybe we didn't get told, or perhaps the mechanical contractor decided that I can actually accomplish this with some other piece of equipment than was designed, but meets the intent. And usually they do this for reasons like they can get it or it costs less. There's usually some benefit to them, but they're meeting the design intent of the building and they change something. They may not always tell you. And so the controls guy usually has to stay in contact with everybody in the construction team to make sure that what you think you're doing is the same as what you're actually doing. If a damper size became bigger, the actuator you designed may not work, and now you have to get a bigger one. And if you find out at the very last minute, you might have a hard time getting the pieces you need in order to make this work right. So when I say confirm sizes against approved submittals, usually that means digging through all the submittals that the other contractors have produced, anything that relates to you, something that you're going to tie into, to make sure that you actually see the same thing in there that you think you expect to see. Or sometimes you'll find something really interesting, like the sequence of operation says uh, modulate this pump, and you're not responsible for providing a modulating pump or the modulating device, and you find out that nobody provided a modulating pump. And you might ask yourself, how am I going to do this? Good question. Something we'll get to in a little bit, but it comes down to asking the construction team, what did you want to do here? But these are the things you have to pay attention to because you can catch little things along the way, and the earlier you catch them, the better. Let's see what else we have here. Lay out your network for all devices. An automation engineer, more often than not these days, has to be a network engineer to a certain extent as well. So you're going to be laying out Ethernet cables, serial COM buses, paying attention to transmission lengths. Again, how much power you have for a given run. It usually is not to the level that you would have to get any kind of certification, but you have to understand how networks operate. So paying attention to that now. And this is a good thing to know if you're coming out and you're going to try and get into this field, you're going to get asked, do you know what an IP address is? Do you know what DHCP is? Do you understand what a subnet mask is and why you should care? Maybe you're used to seeing this terminology when you're hooking up to a wireless network and you're saying, okay, and it says your IP address is 192.168.0.1. Probably not that one, but these are things to understand and pay attention to. So when you're walking into an interview and they ask you this and you say, oh yeah, I know what those are, that's kind of a good thing because honestly, the world is really heading in that direction where everything is network capable. And really amazing. It used to be when I got started, it wasn't the case, but now uh, sensors, which used to just be a signal, are now capable of being on a network. Actuators and relays are capable of being on a network. You can have entirely network component buildings with one head end that sits there and holds all the master programming and not have distributed logic, which is also another standard architecture type. VFDs for pumps and fans are completely network capable and can be controlled over the network instead of using hardwire components. Hopefully that means something. I've even come across valve actuators that you could talk to with your phone over Bluefield or near field communication fully configure them right there and operate them. And so the world of network components is really drifting into the industrial space of automation, and it's only going to become more. So it really behooves you to at least understand at a basic level how TCP/IP network communication works, because you will use it. Other things engineer does, research equipment. We kind of talked about that already. You're going to get a boiler and you're going to look at it and you want to know, how does that boiler work, or how does that rooftop unit work? How does that uh, reverse osmosis water skid work? It's amazing how many things that you can work on that come from other manufacturers pre-packaged into packages that are going to show up in a building, and you're usually going to be the one having to tell it what to do or when to do it. A lot of times it might be something that does everything by itself, but the automation system is going to be responsible for telling it, it's your time to go now. And you have to figure out, how am I going to do that? Do I use a relay to turn the whole thing on? Is there a sequence of things that are going to have to happen? Do I need to talk to it over some software communication integration? I have to figure out, what kind of points does it have? How does it talk? Um, can I even tell it what it is that I want it to know? Everything that you're going to touch in your system, you have to look at, understand, and figure out. That's actually one of the appealing things about being an automation engineer, is you're not going to just be doing pumps forever or one kind of static piece of equipment. Uh, Technology is changing over time, and it's changing more and more rapidly as we go. The automation engineer lives in that technology world, and they have to more or less stay on top of a lot of that, because the equipment that you're going to come into contact with is constantly changing. And you will constantly come into interaction with lots of different manufacturers. And they all have their own unique little ways about how they want to do things. And they're all kind of the same, but a lot of them can be different in interesting ways. And so you're constantly learning, coming up against new types of things that you probably also didn't know. You get into automation, I said, a lot of people may not know what you do. Uh, the funny thing is, you'll go find equipment out there that you didn't know existed. And you'll get to learn about it because you have to integrate with it. You have to make it work. At the end of the day, the automation engineer usually has the job of making everything work correctly. And when something doesn't, it's the automation engineer's fault. uh, you get to deflect that. No, 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 no. I told that thing to run and it didn't run. But you have to figure out at some level how to get in there and be with everything. You get to analyze location criteria, choose correct sensors. Kind of went over that a little bit already, but pay attention to where sensors are going to be. Sensors are designed to be most accurate at specific ranges and particular mediums. Are you measuring airflow or water flow or temperature or humidity, gas particulate levels? What are you trying to measure? Where's the best place to measure it? Um, What's the best sensor to do it? Where do you actually care? Sensors can usually span a huge degree, a range of measurement, but maybe you only care about a certain range. And so you'll choose your output of that sensor to give you the most accurate view, so for wherever you care about. Um, yeah, and the where is very important. Where are you going to measure something, right? Maybe I'm measuring hydrogen gas. I'm not going to put that sensor on the floor. The hydrogen is like going to go up towards the ceiling. So I put the sensor measurement point uh, up near the ceiling where I expect that gas to accumulate. Let's see here. Design power distribution for the BMS managed equipment, right? We talked about that a little bit. Power supplies, voltage drop. How big are my components? How much power do they draw? Do I have enough? Um, and then we get all the stuff, we put it in a design package and we submit it for approval. And the best thing you can do is find problems and solve them now. Any problems you don't find, this is probably the same in every industry you'll come into, solve your problems as soon as you possibly can. The longer you wait, the worse they get. It's amazing how many things can snowball. And I haven't been the mechanical consultant engineer or the electrical, but if you find out later on, um, I didn't properly size some power load for X device out in the building, Now I have to increase my power load, or I have to change something, or maybe at a level back, I totally forgot that I had to control some exhaust fan. Totally missed it. I get out there and my installers come out and say, hey, there's this fan we found that's not in your drawings. Did you mean to control that? And I go, oh no, I did. It was in a sequence and I completely forgot it. Well, at a very late stage in the game, I might have to add a controller out there, add sensors for whatever that fan needs to do its job, add some output relays to control the fan, and I might find that I was really close to my power draw limit, and all of a sudden I don't have enough. So now I have to add power supply, and maybe that fan was in the middle of nowhere, so now I have to get communication cables out to it. And if I waited too long and the building's almost finished, now I have my electricians taking apart finished services in order to put in my components that I missed early on. If I'd caught that 6 months earlier, nobody would have cared or noticed. We'd have been good. And so it's really important to be thorough and pay attention to little details, because the longer you wait to catch them, the harder it is to fix them. All right. So I watched the other presentations, thinking about what to say today, and there was a really good one that popped up a couple of times. And one I liked that Craig Ferdinand threw up in his first one was, who do you work for? Who is you want to make look good, right? So as the automation engineer, who do you work for? One is the mechanical contractor. More often than not, the mechanical contractor who installs all the mechanical systems in a building is your client. They have hired the automation engineer to control all of their mechanical equipment. They're your direct point of contact. You want to help them find problems. You want to help them make their equipment work right. And you want to be easy to work with. But they're going to install the pumps and fans. They're going to install the stuff that you're going to control. They want you to actually control it right. They don't want to find out later that it's all screwed up because your programming doesn't quite do what it was supposed to do. They also don't want you to destroy their stuff. Don't run everything at the same time and overpressurize pump systems. Be careful, listen to them, follow instruction, but follow the sequence of operations and make things work correctly. And find problems. If when you're doing your design, you find issues with a sequence or something wrong with the mechanical layout, you want to let them know. They're going to get paid for everything. If they install a system incorrect because it was shown incorrectly, they're probably going to get paid to go back and fix it. They don't really want to do that. They actually want to install it right the first time. That makes everybody look better. So if you find problems, let them know. Usually together you find solutions and everybody's happy. And then if you do a good job, you do everything right, and you weren't a jerk, they might say, I like working with this person. The mechanical contractor has a higher chance of hiring you for the next job you're going to do. Job security, be a nice person, do a good job. You'll probably have a better chance of getting the next one. And that could be a lot of fun people to work with over the time. So next we go to the mechanical consultant engineer. Up a couple of levels. You want to make their design look good, and you do this by making it work correctly. And by correctly, I mean that sometimes you'll find things you want to do differently. That's okay. Usually as an automation engineer, you're going to have an expertise for, at a ground level, if you're the technician, how things operate really. And sometimes it is at conflict with the sequence of operations. You get to point that out. Everybody likes learning. Be generous about it. And but you want to make them look good, right? They design a mechanical system, and when their mechanical system works good and the owner likes it, they look good. And that's really what they're after. So it's important to pay attention to that. Again, find problems as early as you can. Usually, someone who's designing a mechanical system didn't make a mistake because they thought that was a good idea. A lot of times it's something that they didn't know or they overlooked. So it's a good idea to point that out early so that we can make the necessary changes earlier on. Most of the time, it's correct. I'm just throwing out there that problems exist and you get to find them. But more often than not, things go pretty smoothly. So yeah, when you find these issues or oversights, approach them with humility and solutions. Um, depending upon the person that you're coming up with, and communication is everything. Um, you don't want to approach the engineer and say, "You're wrong. Look at this horrible thing you did." No, no, no. You say, "Hey, I think something could be done better here." Give them a chance to save face because they have their own position to maintain within the professional community. And as a professional engineer, you don't want to walk around naysaying everybody else's professional designs. They also have a lot of time and experience to go into what they're doing. You find a better way to do something, or from your particular vantage point, you see a better way to do something, approach it from a state of, "Hey, I think we can do something different here." Come with solutions. Don't just say, "You totally messed this up." Consulting engineers can be your cheerleaders for new work because they have the ability to specify you or the company you work for in future work. They have the ability to promote your company for future work and come with you as part of a team, much like the mechanical contractor, for getting future work. So if you can make them look good, so do the consultant engineers. Okay, so the last group that you really, really work for is the owner. It's not direct because you're underneath the mechanical contract. Turn on. How did that happen? I think when we lost internet. Oh. All right. Think so? Yeah. Okay. Lost right after. Okay. I don't know how much I lost here, but for those who are watching and I just went quiet for a while, I guess I went on mute. So I'm going to go back to the owner and start there. And so the owner being the third major group that you work for. Actually, I don't remember what I said anymore. So the reason the owner is important is the owner is someone you're going to be working with for a long time. They're not just part of the construction team. They're the person you're going to be working with for years to come. They own the building. They want the building to work correctly. They want it to work correctly for a long time. And they want to feel like they understand what they're doing. So my first line there is you make the system work and make it accessible. And making it work is just part of the contracting tiered environment. Uh, your job is to install it the way it's shown. You make it work the way it's supposed to work. That's all well and good. That's what they want to. They want the system to operate correctly. But then accessible means you want to be able. What was that? Oh yeah, poor network connection. Oh man. All right. Well, what do you think? Is it coming through? Okay. I great. Not sure what I said that was or wasn't recorded at this point. So okay, so kind of picking up where I was, and hopefully that's at a good spot. Um, we make the building work for the owner, and we're going to work with them for a long time. We want their system to be accessible, and by accessible, I mean they want to be able to operate their own system. They don't want to have to call a specialist every time that they have something to do. And to do that, it means you making sure your system is easy to understand for just about any other layperson, because that's the kind of people who are typically the owners. Even maintenance people have very limited understanding of how automation systems work, or once you get past the basic, I put the pump in hand and it turns on, and I have heat at some office way down the way, that's usually the limit of their understanding. And so you have to install your system at that kind of level so that those people, those kind of backgrounds, can operate the system instead of calling you every day. How do I do this? How do I do this? Hey, it did this. There's a thing flashing on the screen. What does that mean? Okay, put enough text on there so they can understand the code and figure out what's going on, and they will feel better about the system. If they have to call you every time something interesting happened, they're going to be frustrated. This is too complicated. Why did you put this in here? You don't want them to be frustrated, because if they're not frustrated and they're happy with your system, they can also have you come out for future work. We really loved how they did our building, and our building works great. And I can pull up my screens and perfectly understand how everything's going. I want to see that again, right? Uh, there's a lot of different companies that can do controls. There's a lot of different companies that can do software. And if you pay attention, a lot of the reasons some of those succeed or not comes down to the interface. Having the interface that people like, right? Why did Apple do so well when they came out with their iPhones and their little circle dial interface? That was really cool at the time. People liked the interface, they could work with it easily. They did really well. So, yeah, like CE owners, owners can specify future work. They like what you do. They want to have you out again because they want to have that same experience. They don't want to be frustrated with their buildings. Um, Sometimes this means small changes. Sometimes this means deviating from the scope. Or when you're doing training, that's like, I really wish it would show me this. And you might decide to yourself, that's not a very big impact. I'm just going to take care of that for them. And those small little nuggets can actually go a very long way. And that kind of comes into the relationship that you will form with a lot of your owners and customers throughout the years. I'm going to warn, don't make wild or complicated tangents from the base scope. Uh, you might think, this is really cool. I could do this. Once you start getting into programming and you're pretty new at it, and you realize the range of things that is open to you, I could do some pretty amazing things. The more complicated you make it, the more likely you're going to have something interesting fail for you that you did not think of going into the future. And having done these kind of things, sometimes they can come back around to bite you. Or you did something really cool, and I just snuck this in there because I had spare time and I thought that was really fun. And the problem is later I own it. And what went from being a very simple system that I could just hand to them and thinking I was doing a good job and giving them something extra for nothing, turned out I owned that later. And that turned into a major pain in the butt. So you got to be careful how far you go or how much you give, because ultimately the goal is you want it to work. You want it to work as the design intent and not be too complicated so anybody can manage it after you. And what is it? If you find issues, let the team respond to the owner instead of you. This is actually a good relationship, communication, chain of command thing. If you find a problem in the design, or if you find a problem, something that needs to be changed, do not just go to the owner and say, this is screwed up, or this really needs to change. This is bad right here. No, tell the contracting chain that something is bad right there. Tell your mechanical contractor or your consultant engineers, hey, I see this thing we need to fix. Let them tell the owner, because that's them saying, we found a problem. We're going to fix it for you. not the guy at the very bottom tier found a problem and decided to broadcast it to the world. That's going to make everybody angry at you. Let the people who design these systems save the face by fixing it and doing the right thing for the team. It's an important one there, and I've watched people kind of low in the totem pole just walk in and say, "This entire system is a piece of shit," right in front of the owner, and the owner goes, "What? Well, how?" And suddenly they feel very insecure about this building that got created for them, and it really created a bunch of bad will amongst the team. Uh, you don't be that guy. This is basic communication. All right, so now we talked about who you work for. Who do you want to keep happy? And I got seriously, don't be a jerk. You want to keep everyone happy. And one of the biggest reasons is, as the controls guy, you make everything work, but because you make everything work, everything else has to be there before you can make it work. So you're the last person on site. Uh, you show up at the very end, and that means everybody on the job site has a chance to make your life difficult. I've had sheetrockers put sheetrock right over my back boxes in the wall. And you come back later and go, "Where'd they go? I was pretty sure I had a box in the wall for my thermostat. That's weird." Spent some time later, found out that sure enough it was there. Sheetrockers came out and cut a small hole for me. Didn't matter to them, but I spent hours trying to figure out what in the heck happened. Hey, call my electricians. I was pretty sure you put something in the wall here. Where did it go? Oh, I did it. Yeah, yeah, yeah. Come out here. We spin our wheels for a little bit, ultimately solve it. That was just them making your life a little bit difficult. There are so many degrees in which that can happen in a construction site. You do not need to walk around a construction site spouting that I am better than thou because I control all of your equipment, because lots of other people find unique little ways to make your life difficult. Lots of them, right? Electrical contractors, general contractors, painters, sheetrockers. Painters can paint over your things, and accidents can happen. Construction sites can be kind of contentious. Sheetrockers, balancers, commissioning agents, specialty startup tech. Some of these are really important. You actually want them to be your friends. Balancers are fantastic people to get to know and understand how to talk their lingo and give them exactly what they need, because they can make a startup be very painful for you by making you hold their hands through the entire process. Or if you work with them and give them the tools that they need, they can be almost an invisible presence where they get their thing done and they don't involve you at all, and everybody's happy. Commissioning agents, uh, very important to keep these guys happy because they can ruin the end of a job for you. Commissioning agents want to show up at a job and they just want to have you show them how the system works and it goes flawlessly, and they move on and they find a couple problems and justify their job about how we got them and they got it done right. Do not let a commissioning agent show up to a job that you are not ready to show them, because that makes them cranky. And when they're cranky, they don't trust you and they can make your life difficult. By that, I mean, let's say you have 200 VAV boxes in a building or 200 zones that you have to check out. And they might say, "Hey, let's check out the first one in super great detail." "Oh, yeah, that looks good. Okay, cool. Let's go to the next one. Super great detail." By the third or fourth one, they're a little bit bored of doing super great detail, and they're starting to trust that your system is working right. So when you back it up a level and show them at a level, and you better believe it works right. Don't think it doesn't when you walk them in there, but gives them that comfortable feeling that they can back it up and they can start looking at it from a higher level and, okay, it looks like you're doing a really good job. But if they're cranky, you piss them off, they don't get that trust feeling because you didn't show them a working system when you got going. Oh, they're going to stick at that low level, and that commissioning time is going to take a week instead of 2 days. Maybe you have the time to kill, maybe you don't. Most of the time, you want to get out of there and go do something else. You already did your job. You don't want to sit there and hold someone's hand the whole time through. So it's good to be truthful and make sure your system works correctly when they show up. In fact, being truthful is a really important part of that. Don't try to hide those things. Just be upfront. Hey, we're not ready right here. We're going to need an extra day to finish. Maybe people will be cranky but that you're not ready on time, but they'll be more cranky about showing up thinking you're done and you're not. Now you've wasted even more time. There was a day they could have done something else instead of showing up to watch you not show them the correct system. Specialty startup techs. This is a good group. You'll know them very sporadically. They'll come in, maybe they'll have a piece of equipment that comes from some manufacturer out of state, and their job is just to verify, oh, power's here, all the things I need. They'll turn it on, they want to watch it work. Frequently, your job is to make that equipment work after they're gone. So you kind of want to be around when they're there and get to know them and be friendly and ask questions like, how do I make this work right? Because you don't want to break it afterwards. And after they're gone and everything magically works right, things can very easily stop working right. And so it's good to find out what parameters are important. How should I sequence my turn on, uh, my enabling process? How do I control this so that it does what I want, doesn't break the equipment, and everyone's happy? Uh, it's important to catch them because they can come and go very quickly. Their job is to get in and out as rapidly as they can. And you kind of want to catch them while they're there, be friendly. If you just don't tell them, if you don't tell them things like their stuff is wrong, they'll usually be willing to help you or point you in the right direction. All right. So now, how do you keep the team happy? And kind of bit into little bits of this already. It's communication and attitude towards a construction site, towards a construction team. A lot of people are confused by automation engineers because they don't understand what we do. That can maybe lead a person to thinking that I'm a little bit above it all and I have all the right answers. And as you maybe have heard in previous presentations, that's not true. You know what you know, but you often don't know everything. So be honest about what you know and don't know. Be honest about where you are in your status. I mean, obviously do due diligence in your job and make sure that you're on top of things. You don't want to be falling behind when the rest of construction is moving ahead of you, but be honest about where you're at. Be concise. Nobody needs a drawn out story about why a temperature sensor isn't installed correctly. Temperature sensor isn't installed correctly and we're going to fix it. Okay, that's all anybody cares about. Not Bob showed up with pizza one day and spilled it on the sensor or on the location and the electrician got confused. Nobody cares. Don't talk down to the team. Same thing, just because you control almost everything, that doesn't mean you own everything. Doesn't mean you know everything. And that goes hand in hand with respect trades and manufacturer startup techs. Frequently, they know unique information about stuff that you're controlling that you need to know in order to do your job correctly. And even though you think you know all the answers, be open to the idea that you don't. And that's something you're going to have to carry with you forever. Uh, I've been doing this for having a couple of decades, and I'll tell you, I do not know everything. And if I feel like I don't, I'll be honest. Hey, how do I do this? Or I'll start up when I see a boiler tech starting off a boiler. Pretty sure I know how to do that. I've done that a lot of times, controlled boilers. But I'll ask them, hey, is there anything unique about this boiler that I need to know so that I don't screw it up? And they don't want their equipment to crater, so they're willing to tell you, oh yeah, if there's anything unique, make sure you do this when you turn it on. Give it 90 seconds to do some purge cycle before you engage this. Okay, cool. I write that down. I basically add it to my sequence of operations and I add that information into my programming so that everything goes smoothly. But I'm respecting what they know. Respect the plumbers, respect the electricians. They have a unique viewpoint on the knowledge that they have. And when I'm trying to achieve my goals, I need their buy-in. I need their support. And so I have to listen. I want to listen to what they say. They may have something interesting that I didn't know or something that helps the system overall. When you're pointing out issues, give others a chance to save face. This is one that I kind of learned early on, which is really good for communication and just life in general, if you can hold on to it. But just telling people flat out that they're wrong rarely ever works. And usually you want to point out that, hey, I think something's not right, and I think maybe we could make it better with this. Have solutions in hand, have an idea in hand. But when you know that a particular individual has something wrong, you can make an enemy by telling them that they're wrong. Or you can suggest that maybe we could do it better like this and allow them a chance to pick a different route. And depending upon how strongly you feel about that, they can choose that they could still choose that you're not right. And it's not your design. So you may just go along with that. If you really feel like this is a serious problem, you still want them the chance to make that design change without being forced. So you have private conversations. You don't broadcast problems to an entire group. You pick where your communication channels go, because no matter what you think of that person, you want them to have the chance to reflect their professional standing in the community, within the construction group. And if they feel like they have that standing, everybody's happier. It all kind of flows together smoothly. And if you made an enemy accidentally, now they're going to make problems for you later, inevitably. So being gracious with humility in how you approach everything is really an important aspect of communication, especially in controls, because we come in last. We make everything work, but we're the last ones on the team. Uh, and because you have to work with everyone, figure out how to be gracious with everyone. And that goes right into Alaska is a pretty small place. And if you come off with a reputation as a jerk, people are going to remember that. Or a great person to work with, people are going to remember that. There are only so many contractors and places to work in Alaska. And at some point, if you've been doing this long enough, no matter what industry you're in, you will become known if you stand out as an exceedingly good or horrible person. So horrible people tend to get weeded out. I have seen a few which magnificently managed to keep on working and thrive even though they were horrible people, but not very many. Got a couple of names in mind. I'll keep them quiet. All right. I think it's because they were really good at their job. Moving on. Construction hierarchy stuff to watch for. And I'm over an hour already. Controls is the last team on site, making you affected by any schedule delays. When they're pouring concrete at the very beginning of the building and the concrete is late by a month, the general contractor is unhappy. But at the very end of a job, they still want to do it on time. How are they going to make up time? Oh, they'll pressure the controls guy because he's very last. And everybody else's slow down schedule impact you. Fortunately, you protect yourself with documentation. I have a startup letter I like to throw out that says, when all of these things are done, I will come outside and I need this much time. And if they didn't give you enough time or all the things that you need, you told them early on, hey, this is what I need in order to do my job, and you didn't give it to me. So I'm sorry about your schedule problems, but you cannot just crunch me because you want to. It's pretty important because otherwise you can get pushed around an awful lot by a GC who says, you got 2 days to be done. How are you going to do it? I told you I needed 3 weeks. I don't know how I'm going to do it. Follow the chain of command. And really what this means is for who you talk to about what. If you're hired by the general contractor, your documentation, your submittals, your requests for information, they all go up through them. And they take your information and they pass it up to the next person in the chain of command, which is usually the general contractor. And from there, it goes up to consultant engineers. And then after that, maybe the owner. Do not simply ask a question straight to the owner if you can help it. Do not go around that chain of a command because that makes all the people in the middle very cranky. It's not always because it's a bad thing, because they want to be in the know. They want to make sure that you're not making promises about some part of the build of the building that they are not a part of. They don't want you to agree to something which maybe they thought they could have got paid for, or was out of scope, or complicated their lives in any way. They want to avoid that. They want to make sure that they're part of all the conversations. That said, when you're really short on time and you need to have some decisions made right now, I have been slapped on the hand for talking straight to a consultant engineer and going around the contracting team. And some contractors care about that more than others. Depends upon how high profile the job is. Worked in missile defense. They didn't like that very much. But usually, if you do that in the essence of time, you call up the mechanical engineer and say, I really think we should do it like this. And they agree, okay, we're going to make this change. You follow it up with documentation, and the documentation says something like, I recognize that this situation is going on, and I highly recommend that we do it like this. And this is a conversation that you have pre-worked out with the consultant engineer, that I'm going to word my RFI in exactly the way in which it goes through and gets approved very quickly. But on the back end, we've already made the decision to make this change, and we can already enact it because we know it's going to happen. So we get it done on time, and everybody is happy because documentation flow happened, and everybody was made aware. 9 times out of 10, that works out pretty well. Sometimes someone along the way creates a kink, and yeah, usually it's not a big deal. But I've made some GCs pretty cranky by trying to bend the rules. Um, yeah, but as far as hierarchy, it's really just the chain of command and paying attention. Um, some traits for a good engineer, for a good automation engineer: embracing under electronics, understand the circuits and the system you mean to control, understanding voltage, current, resistance, but also understanding the mechanical principles, not just what voltage it required to trip a relay to turn on a pump, but understand what that pump is, how big it is, understand all the principles around what you're doing. Have a high attention to detail, which I kind of went on about earlier, catching problems early as you can. You solve that by having a high attention to detail and trying to imagine all different scenarios that can happen to your system and reasons for why you might want to control something. Having to make revisions after the fact is usually a lot more difficult to fix. Alaska is a big place. Usually means you get to travel in Alaska. Uh, if you have the aptitude or interest in travel, it's a good thing because you get to go to places most people do not. And I grew up in Alaska, lived here for 20 years, and really only went to the major places, right? Fairbanks, Anchorage, Valdez, which I guess isn't that major, but you stick to the road system. And when you start working in the contracting world, construction world, there's construction all over the state for all kinds of systems. And you will have the opportunity to travel to lots of places that most people do not get to go. And it's actually pretty interesting. And if you're open to that, um, it can be a really good thing for you. Be open to input from other trades. Don't, kind of reiterating what I've said before, don't close yourself down as someone who has all the answers and knows all the things. There's always new innovations happening. There's always systems that you've not encountered, or systems that you're just not as good at as the special tradesman. Be open to criticism, be open to alternative ideas. Accept finding mistakes and fix them. Other people are going to point out your mistakes. And rather than being defensive about that, take a posture. Hopefully they gave you that chance, right? I reiterated a couple of times, give someone else the chance to save face and fix their own problems for the group. Hopefully someone else gives you that same opportunity. You get to fix your own problems, accept that, and learn from it. Hopefully it's one mistake you don't make the next time. And then respect yourself. And I got a lot of years of not doing this in the way that I've got it written. It's very easy to be pushed around in the construction world, and you need to learn how to set boundaries. Overtime is going to happen, uh, but don't let it burn you out, right? Overtime in bursts is good, and it gets things done quickly, and it can be kind of fun because all of a sudden you got a deadline you're trying to work for, and you don't have a lot of time to do it, so you're working hard. But recognize the limits, and don't let your employer uh, push you into a situation where you're doing overtime all the time. Because as that drags on week to week to week and month to month, that will burn you out. And some people have more or less capabilities of doing that and handling it and managing that, but it will burn everybody out if you do not set some boundaries so that you're given your own personal time. And then, as a part of respecting yourself, always find that opportunity to grow, learn new things, accept input from other people uh, who are there to teach you things. And if you're friendly, will often teach you things you didn't know. And it's not always stuff you knew you wanted to know, but just kind of keep adding it on, because growth is not really a cliff. It's a progression of new information and skills that you pick up along the way until all of a sudden you didn't mean to, but you turned out to be really good in your field, and people are looking to you for answers instead of you looking to other people. And that's kind of a fun place to be in. Uh, but you have to leave yourself open to listening and learning from all those around you. And that's kind of the end of my presentation. I don't know if there's any questions that have been typed in, but if not, then hope everybody's had a chance to learn something, and have a good afternoon. All right, sweet.